In this video, you learn how you can use ultrasonic sensor with Arduino Uno R3 to measure distance. These are the two mandatory components, and any means of connecting these two, I will use jumper wires and breadboard. Start by connecting the GND of ultrasonic sensor to GND of Arduino, echo pin to digital pin number 13, and the trigger pin to 12, and the VCC to 5 volts. You can use any pins for trigger and echo. To follow this tutorial, make sure to use this. Ultrasonic sensor works on the principle of sending the sound waves to an object. These waves are unhearable to humans because human ears can only listen to waves under 20,000 Hz. Ultrasonic sensor like this use 40,000 Hz waves. The waves come from transmitter. This is transmitter and this is receiver. The waves go from transmitter to object, bounce back to the receiver, and then we check how much the time it did take. The main concept can be learned by the code. Now this is all the code you need for your ultrasonic sensor and Arduino to measure the distance wirelessly, no physical connection. The first thing is you need to know that the 12 pin is trigger pin which is using for output. The trigger pin is directly connected to transmitter, meaning turning on trigger pin would turn on the transmitter and the wave would start traveling. The 13 is using for input and is for echo pin using and is directly connected to the receiver pin. We initialize the serial communication. Now this is the main concept. The first thing is the 12 pin is trigger pin, meaning we are turning off the traveling wave for 2 microseconds. We are using microseconds because the pulse-in function that you will learn later uses microseconds. And it also gives us fast calculations. Then we turn on the waves for 10 microseconds and then turn it off again. The main thing is the speed of sound in air is usually 343 meters per second. To convert this into centimeter per second, we just gonna multiply it by 100. We are converting meters, centimeters, because the maximum range of ultrasonic sensor is only 700 centimeters, and for precision we use centimeters. As I told you, the pulse-in function uses microseconds, so to convert per second into per microsecond, we just divide it by 34,300 centimeters, which gives us the speed of sound from 343 meters per second to 0.0343 centimeter per microsecond. Now let's talk about the pulse-in function. As I told you, the ultrasonic sensor just sends waves, and then when it receives, it checks the time, and by using the distance is equal to time multiplied by speed formula, it gives us the distance. The pulse-in function is connected with duration. Duration is a long variable because the pulse-in function will give the values in microseconds, and microseconds are at least 1 million for 1 second. So this is why we are using long variable. To give you more idea of pulse-in, when the echo pin, the 13 pin which is using for input, as soon as its state changes from low to high, meaning it has started receiving the transmitted waves, it gives us the time in microsecond. Before receiving the waves, the receiver was at low, 0. Echo pin was low. As soon as it changes to high, the time taken from turning the state from low to high, it puts that amount of time in microsecond in this variable. This is why we calculated the speed in microseconds and also use in microseconds. And this is when we get the time in microseconds, not seconds. So just using simple integers like distance, we multiply the time, which is duration we get from pulse-in, and multiply it by speed of sound and dividing it by 2. We divide it by 2 because the wave first travel, then bounce back, and they are double the amount of time because we only need the time it takes the waves from transmitter to object, not coming back. We don't need the coming back wave, which is why we divided by 2. The rest we use simple serial.print, which won't use new line, and then serial.print ln, which uses new line for our convenience. We just put this variable in here so we can see how far is the object. Let's upload the code and check. Let's first put our scale and put the object perfectly 18 centimeters away from the ultrasonic sensor. Let's open the serial monitor and you will see that the distance is as precise as possible, 18 centimeters. Meaning our calculation and our ultrasonic sensor is working perfectly fine.